I'm John Golia.
And I'm Greg Fife. And we are
the Flight Safety Detectives.
We're just two guys who have spent most of their career with the National Transportation Safety Board investigating aircraft disasters and aviation safety issues all over the world.
Yep, and this podcast is where we talk about everything from accidents, airplane technology, to the big business of aviation.
We live and breathe aviation. My co-host John has been in the aviation business for more than 60 years. He was the first and only airframe and power plant mechanic to get a presidential appointment to the National Transportation Safety Board.
And Greg is a former air safety investigator and GO team captain for the NTSB. He's investigated everything that flies worldwide since he started his career 40 years ago. And on top of that, he is a Living Legends of Aviation inductee.
So between John and myself, we have over 100 years of aviation safety experience. It's time to buckle up because it's going to be wheels up. Let's get this show in the air.
Well, my friend, it's another episode of Flight Safety Detectives, and although we are not together in person, we are together virtually, so it's always good to see you, John, and I'm looking forward to this episode of Flight Safety Detectives because of recent events involving a United Airlines Boeing 777 and an engine that decided to come apart and shed parts all over Broomfield, Colorado. I'm going to really look forward to your expertise since you are the master and the guru of maintenance issues and these late events and things like that. But I also want to take this moment to thank our sponsors because I think this is going to be a good show, as all of our shows are. But I want to thank PAMA and, of course, Avemco Insurance.
Yes, any of our listeners out there are renewing their policy or getting a new policy for maybe a new airplane, whatever, give Avemco a call. They're 888-879-0389 or avemco.com. And if you mention Flight Safety Detectives, you can get yourself at least a 5% discount. That's pretty nice just for mentioning Flight Safety Detectives.
Yeah, absolutely.
And I know, Greg, you've used them to insure yourself and your airplanes as well as actually had a claim.
Absolutely. I sit on the board of the National Association of Flight Instructors, and Avemco is one of our sponsors. So if you're looking for supplemental or personalized insurance as a CFI, definitely call Avemco. They offer those policies and a lot of other policies. So I've always had great luck with them. They've taken good care of me, and I like being able to deal direct with the insurance company, not through brokers. So thank you, Avemco, for sponsoring Flight Safety Detectives. Well, my friend, we had some excitement out here, not too far from both my office and where I live, with a United Airlines Flight 328 that was actually heading from Denver International out to Honolulu. Unfortunately, they didn't make it very far. They made it less than 50 miles away from the airport before the number 2 engine, one of the fan blades on the number 2 engine, decided to let go, which led to a catastrophic mess. Unfortunately, the engine cowling on that airplane was breached, and during the course of flying it 250, 300 miles an hour, the combination of the damage by the blade and aerodynamic forces just shredded that cowling, and it came raining down over a populated area of Broomfield, Colorado, which happens to be where my office is. And it's very, very fortunate that these heavy structure pieces that have been all over the internet, pictures are all over the internet and on TV, did not strike anybody, whether it was an automobile with cars or go through the roof of a house to kill people. There were some parts that did go through the roofs of houses, but it was a blessing in disguise. And then on top of that, the crew just performed very well in handling the situation. And when you look at all the dramatic video that passengers were shooting and then, of course, making public, you would think that this was more of a disaster than it actually was. The crew was very professional. You and I were made aware of things that the crew had discussed in their interview. But it sounds like they were extremely professional. It was a seasoned crew. Both pilots had a lot of experience, both total experience and, of course, on the 777. And it sounds like it couldn't have gone any better given the circumstances.
It just shows you the quality of the crews when you train them well. These guys have been through United's training. United runs them back through their training every 9 months right there in your backyard in Denver at the training center. And these guys performed like a crew, not like two pilots in the cockpit. I love the fact that when air traffic control tried to give them instructions, they asked air traffic control to hold on. They were running the checklist, unlike what we saw in Lion Air, where the first officer was blabbing away with air traffic control when he should have been assisting the captain in dealing with the emergency that they had. So this crew was very professional. They were very coordinated between each other. They were knowledgeable, like you said. I had somebody tell me that the first officer's got over 4,000 hours in these 777s. Plus, he's a high-time pilot anyway, almost 20,000 hours. So well experienced. They were really two co-captains, even though seniority has one as captain, one as first officer.
Yeah.
So what was going on in the front of the airplane was exemplar. They had an air traffic controller that really was on the game. I mean, he cleared the traffic out of the way. He told them, whatever you want to do. They were prepared to handle it and to get him back. So it was, yes, it was an emergency, and it was probably difficult for the passengers on board, not knowing all that at the time. But in hindsight, they should be feeling pretty comfortable that they had a good piece of equipment. They had an excellent crew. They had air traffic control that was functioning above and beyond. It was a perfect scenario for the event that occurred.
I agree. There's a number of issues, though, John, that really concern both you and I. I posted something relatively early on Facebook with regard to issues that you and I had discussed at first blush immediately after the event were concerning. Of course, the fan blade issue, because this is not the first event involving these particular fan blades on the Pratt & Whitney 4000 series engine. We had an event back in 2018 involving another United 777. And then later on, last year in 2020, there was a Japan Airlines or JAL 777 that had experienced a blade failure. But I think, as you told me, this was the more catastrophic of these events because the entire cowling came off and did significant damage.
Right. We haven't had the cowling come off like this in those other events.
Yeah, and I'm going to ask you about the certification and the requirements, but I wanted to get to the real meat of you and I, other than the blade, and that was the residual fire that continued to burn well after the cowling left, and we know that the crew pulled the fire handles. And the concern that you and I had to the fact that if this aircraft had been out 2 hours out over the ocean with a fire like that still burning, what would the outcome have been? It sure wouldn't have been successful like it was here in Denver.
It could have had a much worse outcome. Interestingly, I read a comment in USA Today, and I saw a couple comments from people that probably shouldn't have been commenting because of the jobs they have, that were talking about that's the fire that's inside the engine. I just couldn't believe somebody would say that had any kind of knowledge of an engine. But what you see burning there is actually some composite material that lines the inside of the fan duct into the engine. That is not the inside of the engine as such. The engine lives in the middle, and it's only a fraction of the size of the engine that's on the wing. So this is burning on the outside. It's in the fan duct. Those are the cascading vangs that we're looking at for the thrust reverser portion. It's made of composite. There's a lot of composite in the fan duct and parts of this engine. One of the byproducts of composite material is that when it catches fire, and it's not easy to catch fire, but when it finally catches fire, it's not easy to put out. It just continues to burn and burn and burn. And you can see that. Here we have wind 200 miles an hour, almost 300 miles an hour, airflow, wind blowing through here. And you can see how it goes right down to the point, and then something happens and it slows down. The gust maybe turn the other way. Something in the engine makes it go the other way, and it will flare up again. And that's exactly the properties of many of the composites that we use today. You won't get it out.
One of the concerns, because of the intensity of that fire, and then finding out that fire continued to burn for about 30 to 45 minutes after the airplane was on the ground. My first thought originally was it had to have been some sort of magnesium part, because, you fire off magnesium, it's really hard to extinguish. But then as you and I were finding out more about this graphite and composite material, it kind of burns and has the same characteristics as magnesium. It's very difficult to put out.
Yep. And some of these composites are backed up by metal. And I don't know, and I haven't been able to find out, I haven't had time to really do a lot of digging, but I don't know what metal material that they use. And it could be magnesium, because the whole purpose is to make it as light as possible. So it's certainly not stainless steel, because that's heavy.
Let's step back a little bit, John, and pick your brain about these fan blades. We've had fan blades and other blades, compressor and turbine blades, fail on a variety of different makes and model engines over the years. I mean, that's just the nature of the game for a variety of different reasons. But what's going on with these specific fan blades? And better yet, I know there's been a lot of talk, a lot of chatter on Facebook, other social media sites, and of course TV, with a variety of talking heads who have tried to talk with a level of knowledge about these blades being hollow. Well, we need to explain that, I think, a little bit, because there's a practical reason why those blades are hollow, and nobody's ever explained it that I saw on TV or on social media. So if you could just give us the Reader's Digest version of why those blades are hollow and what's happening with those blades to cause them to fail.
All right, so this engine is 112 inches in diameter. So these blades are long. They're probably 50 inches in length, and I'm guessing. So there's a little bit of fudge in there. Down at the root, towards the center of the engine, they're pretty thick and solid, because that's where they attach. And that attachment point has to hold these blades in place under varying loads. All right, so the first load that they have is centrifugal force. The fan is rotating at around 3,000 RPM. These blades weigh in the neighborhood of 30 pounds each. So the centrifugal force on that attachment point down at the bottom and towards the center of the engine is rather high. Not only that, but the blades, because they're drawing air, pulling it in, they're actually being pulled forward. So you have that sort of energy acting on the blade as well. And when you hit a bird or anything comes in that engine, it pushes it back. So the blade has to be able to withstand both the forward bending motion and an aft bending motion. And, and plus you get hit with hailstorms sometimes. Some of those hailstorms will generate ice balls that are the size of tennis balls. And those are slamming into the engine. So there's a lot of different forces that act upon those blades, and it has to be able to handle them. If those blades were solid, they would weigh well in excess of 30 pounds. They probably weigh double what it is. So they're not exactly hollow. There's a webbing inside those blades that continues from the root all the way out to the tip. So they're hollow, but there's reinforcements inside. And the leading edges are thicker, and the trailing edges are also a little thicker. That is the root of the problem that we're having, that webbing inside. And there's a few pictures running around on the internet that, if you know what you're looking for, you can see that. It looks like on one of them, when you look at the engine and they're sort of showing you the stub that's still attached to the hub of the engine, you can look in and you can see the hollow spots in the metal.
And I think we're going to put some pictures up on our website so that people can actually see what you're talking about.
All right. So the inside is like a waffle, and the dips in the waffle would be hollow all the way down, but there's a network of reinforcements in there. That's where the problem is. As these blades are going through their life and getting exposed to all these stresses that they're under, they start to crack on the inside, not on the outside. So when you do an inspection, the outside looks fine. The problem is on the inside. And it's very difficult sometimes to get an inspection method that can get inside the blade without destroying it to determine that it's okay. Now, after the 2018 event, the engineers at Pratt & Whitney went through and developed a very special non-destructive testing, NDT, process that they could inspect the insides of these blades with a high degree of repeatability. So they've developed that process and they've been inspecting the blades. So now the first question that's going to come up to the investigators is, was this a failure of the person doing the inspection? Was it a problem with the person, with the inspection method itself? Or was it a problem with the tooling? So the NTSB, I'm sure, is going to take a good hard look at that, the FAA as well, to see if, in fact, the inspection method is adequate for what needs to be done. Now, the first thing the FAA did was reduce the hours between the inspection intervals. And I don't know what the intervals were, but whatever they were, 1 year, 2 years, 3 years, whatever they were, the FAA cut it in half and said from this point forward, you're going to do those inspections at half the time you were doing them before. Meanwhile, they're working to find out if there was a problem with the inspections or the person doing them. And also, is that method the appropriate one? Have we developed newer methods in the 3 years or so since that 2018 event? And is there a newer method that we could possibly use to have better results? So there'll be a lot of work going on that front.
Let me ask you a question, John. You mentioned that this is a proprietary inspection process developed by Pratt. Is it because that's a business revenue generator for the inspection and they want to keep it in-house, or is it because of the risk of missing something if it's done by others out in the field?
I would suspect it's both of those. One of the problems that you get when the inspections go out all over the place is you lose control of them. If they're done by inspection facilities around the world and they have another engine failure, they're not going to say on the press or anywhere, oh, that was Harry's inspection shop in Singapore who did that. They're going to say Pratt & Whitney engine had another problem. So in some cases, the manufacturer will just say, bring that in-house, bring that back, we need to control it. And then there's a business case for how much money did Pratt & Whitney spend to develop that inspection method? How much money have they had to spend setting up a process, a facility, buy the equipment to do that? And that all comes into the business case side of it. So there's two sides to that equation.
Now, you also just brought up a good point. When I'm looking at social media, listening to people on TV and that kind of stuff, and I've seen Boeing taking a hit for this in this particular event. They say that this is a Boeing problem because some people think that these engines are made by Boeing. I know that you and I, in our interviews, and I've been posting on Facebook, these are two separate organizations. Boeing's responsible for the airframe. Pratt & Whitney, a separate company, no affiliation other than a customer, has the responsibility for the engine. And I know you've been around this because when you worked at U.S. Air, U.S. Air, they select an airframe, but they also are able to select a compatible engine that goes on that airframe. And they're not just given one choice like the engine in your car. You just take whatever comes in your car. Airframers have the ability to have a variety of different engines, and the customer is the one that picks that engine, correct?
That's correct. And usually what will happen is, and let's use this 777 as an example. This particular airplane that we just had the problem with was one of the very early airplanes built. I think the serial number was 4 or 5. So it's from the very beginning. It was actually a flight test airplane, I believe. So in any event, it's an early airplane. While that airplane is on the design board, United has committed to it. United is shopping, or whoever the customer is, they're shopping around the engine manufacturers to see what kind of engines and what kind of deals they're willing to give, the manufacturers are willing to give. Pratt and Whitney was already selling engines to United Airlines. United Airlines had a large fleet of 747s, and this particular core engine is used on the 747. In fact, the one that recently had a problem, I think the number was 4054, the model number. So it was a smaller engine than this one here, which is a 4084. And many people are calling this engine the 4077 on this airplane. But the specs that I saw, it's a 4084. Those numbering systems just mean different internals to the airplane engine. So they'll go and buy an engine. So in this case, United has 24 of these airplanes. So that means they're going to buy 48 engines. But they'll go to the manufacturer and say, I want 55 engines, because they'll never get them cheaper than they will in the very beginning. In fact, the engine manufacturers often say that those initial engines that they sell to the customers of the airplane, they lose money on. They sell them below what it costs them to make the engine, because they're going to get the overhauls out of them later, and they're going to get spare parts sales later. So the airlines will buy however many engines they need for their fleet, plus some spare engines. Because you always need spares in this business. A bird strike will wipe out an engine. You need to have an engine to put on it. These engines can be big vacuum cleaners on the airport. And sometimes people will see signs around. If you go looking out the window, you can see Ford. Sometimes you see trucks running around the airport with that are actually vacuuming the ramp, picking up the nuts and bolts and things that fall off the equipment, the ground equipment, baggage tugs. All that equipment that drops those bits and pieces off it, when these airplanes start up and start taxiing, these big engines will just suck them right up into it. And those end up being dings in these fan blades, which means you have to replace them and they have to go back and be repaired. So it's an endless cycle. So for the last 20 years, there's been maximum efforts at the airport to keep down the foreign object digestion or damage, FOD, around the airport, so these engines don't get damaged. They're incredibly expensive.
Boeing, they don't have the same level of responsibility for the engine as Pratt. It is strapped on their airplane, but that's about as far as it goes. Yeah, they are responsible because engine cowlings are considered airframe parts. And of course, the big deal here is that, yes, this blade let go, and it started a sequence of events that resulted in an engine failure, of course, subsequent fire, things like that. What, in a nutshell, is the requirement for these engine cowlings? We know that they can't be made of titanium or anything, because mechanics have to work on those engines. You can't have things that you can't open up sitting at the gate. And so it has to be of some lightweight structure, because you can't have heavy structure, because that takes away from the carrying load, the useful load of the airplane. So what are the general requirements for the cowling, and why did, like in this case, why did the cowling fail as bad as it did?
All right, so generally, the cowling around the engine serves a number of functions. One is to streamline the whole flow of air around the engine. The fan is going to keep the inside of the engine cool, so the airflow is controlled by the larger diameter of the cowling to keep the airflow going front to back. It's also there to maintain a seal around the engine, because we do have fuel lines that break from time to time. We do have problems where there's a fire on the engine, and there's fire suppressants on the airplane, fire extinguishing agents, if you will. And there's 2 bottles per engine. In order for it to work, you've got to have the cowling. It's got to be able to stay around where the fire is so it can put it out. If there was no cowling there, it would just blow off into the atmosphere. So it's got to be inside the cowling. The cowling has to fit. One of the things as a mechanic we have to look at on a pretty regular basis is that the cowling is sealing. When we open it up, you need to make sure that it's closing and sealing together in a proper manner.
And let me just interrupt you real quick. That fire suppressant agent is halon. It's a gas.
Yes.
So like you were talking about, if you don't have it contained with the engine cowling to keep it where it needs to be directed when it's fired off, and you lose the cowling, it dissipates into the atmosphere. It is therefore non-effective. It's not going to put anything out because you just don't have the concentration of where it needs to be to put a fire out. The question is, this isn't the first time we've had failures and loss of cowling. From my understanding, Airbus has a chronic problem with cowlings coming off of airplanes because of their latches and a variety of other reasons. And if fire suppression systems are so critical on the cowling being intact and in place, why isn't anybody picking up on this, that they come up with an alternative method of fire suppression? Because this fire, like we talked about earlier in the show, if this happened 2 hours out over the water and that thing continued to burn like crazy like it did, all of a sudden now that fire propagates up into a pylon and possibly into a wing and wing fuel tank.
Well, I'm sure that the fire folks at the NTSB will be looking at that to see what could have happened if that was allowed to continue to burn. As I look at the picture and the flames that we can see through that piece of busted cowling, when I look up and I'm trying to see how far up it went towards the top, because the problem is burning where it is, it can burn forever, and it could burn pieces off. Down there, it's not going to matter much. But if that fire continues to go up into the pylon, that's a different story. The pylon is that piece of metal that's in between the wing and the engine, and there's a lot of plumbing in there, including fuel lines, hydraulic lines, and electrical connections. And you certainly don't want a fire that's progressing up into the pylon piece, because now you're getting in close to the wing. And the pylon's attached to the wing spar, and the spar is what holds the wing together. That is going to be a critical piece of the investigation. It may not even make it into the report or make it into the probable cause. By the report, I mean the blue cover, the final report. But it will be in the docket where they have much more information, because that's critical if that fire was allowed to, or could be allowed to travel up into that pylon area. The outcome is not going to be pretty.
Good morning, you're on the ground, Canadian 920. We're just coming up to Alpha Juliet.
A920, runway 248, taxi.
At the time we're doing this show, we know that the blades have been removed from the event engine and sent to Pratt and Whitney for further examination. And of course, we're all waiting to see what that examination shows. The NTSB released some early information about metal fatigue in the root of the blade that they've done a preliminary investigation on. Can you just talk about that history and what metal fatigue is? Because we have a lot of listeners who are very savvy with aviation, but we have a lot of aviation enthusiasts who may not know that.
The fatigue issue that they're talking about is right down close to the attach point of the blade to the hub. And as I said earlier, that attach point is really meaty. It's substantial. It's not hollow. It starts to get hollow as it goes further out. And that's where it breaks right after it becomes hollow, is where at least the first two have. We got to assume that this one is going to be in the same area based upon the pictures that were floating around. So that fatigue is an issue that comes. Remember in the beginning here I said centrifugal force?
Yes.
These blades grow. So let's say, just for the sake of argument, this blade is 48 inches from the base to the tip. Just for argument, that's not an accurate number. When it's running at 3,000 RPMs, it's probably going to gain 1/8 of an inch. It's going to grow. It's being pulled. That's stress on the blade. And it's tension on the blade. And tension brings stress fractures. So somewhere along that blade, it's going to start to experience the effects of stress. And they're usually down at the base because that's where the most of it is, because most of the weight is further out on the blade. So you're going to see it down close to the blade base, and that's exactly what we're seeing. So you've got the stress from centrifugal force, and you also have the opposite direction force because the blades are trying to bend forward because they're drawing in all that air. So they're actually bending forward a little bit, tiny little bit, but it's bending forward. And then when you throttle back, they're going to go straight up again. So it's just going to move just every little bit, but over and over and over. And maybe the simplest way to describe it is if you've ever taken a paper clip and sat there and maybe you're on the phone or something and you bend it back and forth, back and forth, back and forth, and all of a sudden it breaks. That's exactly what you're doing with a blade. You're stretching it back and forth, back and forth, back and forth, and it induces cracks. Now, there's lots of ways that we deal with that. Metallurgy is one. Certain metals mix certain blends of metal with other metals, and it changes the stresses. The stresses are still going to be there, but it changes them in a way that the metal can handle it, and it won't break so quickly. There's a lot of things that the engineers can do with that, and it's a challenge for them. It's a challenge.
Now, again, the safety board in their preliminary press conference called this a contained engine failure. You, me, and a lot of other people in the know have been calling this an uncontained engine failure. Can you just describe the difference between the two? And I still assert that this is an uncontained failure because parts of that engine, the blades, came forward and started the whole sequence of events by damaging that engine cowling, which eventually completely failed due to not only being probably cut by one of the blades, but then aerodynamic forces stripped it off the rest of the engine.
So when Chairman Sumwalt last night said it was technically a contained engine failure, and what he failed to say was that they haven't been able to prove yet, this was the first day that they were there, they haven't been able to prove yet that that blade had, any of the pieces of that blade had come forward. It doesn't mean that it's going to stay uncontained, but by the definition of an uncontained failure is they don't have any proof that a piece of that engine, when the blade came off, left. We know for a fact, because of the work that was done on in 2018, those blades, when they come off and hit the containment ring, which this one did, and made a serious indentation into the containment ring, it had to go somewhere. They just haven't proven whether it went back with all the other debris or if it came forward. But the strong suspicion is that it went forward because that's what the others have done under the same circumstances. So there's nothing to indicate this is going to be any different than the previous two. So it came forward, and it does look to me like it does to you and a number of other people that we've talked to, that metal ring that's on the nose cowl, the very first, the big shiny ring on the front, appears to have been cut in one motion by something. And that something could very well be this fan blade that's leaving at a high rate of speed.
And you brought up a term, containment ring. And again, just to help our listeners who aren't as aviation savvy, what is the containment ring? What's its function? And is that something that will be looked at in this instance? Because it's obvious that if you and I and others are correct and this was an uncontained failure, then the containment ring didn't do its job.
In certification for the engine manufacturer has to demonstrate that if a blade were to break off, it has to demonstrate that it's going to contain it inside the shell of the engine. And the way they do that, and you can see it in the pictures, that the containment ring that in most of the pictures that I've seen is a beige color. It's right in the front, and it's wide. And it's made out of Kevlar, and it's a very elaborate piece of engineering that goes into this containment ring. And in the certification tests, they actually put an explosive charge at the base of the blade with the engine running, and they trigger the explosive charge. The blade breaks and comes flying out, And the engine cannot be certified by the FAA if that blade goes through the case. It has to stay inside. So this ring, this Kevlar ring, has to keep it contained. What's happening in these engines today, it looks like these three, but at least the earlier ones, is that after it comes out and hits the containment ring, it still has a lot of energy. And it has the potential to bounce around inside there. It might even go back and get hit by another blade and go spinning off in who knows what direction. And that's what we're thinking. This is called an arc. And we think that after this blade comes out and hits the containment ring, it is projecting in an arc that goes forward and goes through now what would be soft skin, soft tissue, the fiberglass panels that are in the front end of the engine that make up the cowling to keep it streamlined, and it's going to cut through that like butter. And now with, in this case, between 250 and 300 mile an hour wind, if you disrupt that case, that wind is just going to rip it to pieces because it's only fiberglass with some metal reinforcement.
Now, these investigations are a process. You and I have participated and conducted the process. What's going to come out after the fact? That is, after they've done the examination. This is an old engine or older engine. It's not like they've stockpiled a lot of these blades on the shelf. And if Pratt & Whitney has this proprietary process, that means all the blades on all these affected engines have to go back to Pratt & Whitney. Well, I can't imagine they're going to turn all of these blades over basically overnight. So there's going to be a backlog. There's going to be airplanes sitting on the ground for a while as they inspect these blades. What's the fix? I presume you either scrap it or you find that it's serviceable. But, I mean, how is this all going to work, John?
Well, fortunately, because of COVID, in the U.S., we only have 40 airplanes flying. Actually, it's not even U.S. Worldwide, we only have 40 777s with this 112-inch diameter engine flying. There's another 59 or 60 that are sitting in storage. So if they do find that they're going to have to, let's say, put a time limit on these blades. Some of these blades are probably around from the middle 90s. Let's say that they come out with a decree, the FAA does, and says that any blade made before, and I'm just throwing a number out here, made before 2005 has to be scrapped. Life limited is what we call it. The piece has a limit on how long it can be used. So if we say 15 years, regardless if it passes inspection or not, we can't use it. So that means they're going to have, I'm doing the math in my head, probably 30% of the engines are going to fall into that category of having blades gone. Fortunately, we've got over 100 engines sitting on wing on these airplanes in storage. So they're going to go through their records and they're going to go back and pull those fan blades off and put them on the airplanes that they're flying. And then decisions are going to have to be made on whether or not they manufacture new blades, which is going to take some time because these are not easy things to manufacture. Whether they're going to redesign a new blade and then manufacture it, that's going to take even longer. Or they're just going to retire a bunch of those airplanes early. These 777s that this engine is on are all the early ones. They're 25 years old, the oldest 26 years old. So those were getting ready to be retired anyway. So they may retire a whole bunch of these airplanes that will give them the spare parts to carry on until a permanent inspection method can be developed to allow them to continue to use it. So all of these factors have to get considered in. You've got multiple factors now. It's an equation with lots of knowns and several unknowns that come into it. So it's not going to be an easy process.
Let me just ask you a couple of questions as we wrap up this discussion. I've heard other people, I've seen it on social media and on TV, talking about the CFM engines on 737s and some other in Rolls-Royce having similar issues. What's the issue with their blades? Is it similar to what's going on with these blades? And can you really equate what's happening with a different engine on a different airframe to this?
It's a little bit of both. All right, so both Rolls-Royce and GE CFM And actually the V2500 as well, which is another engine, they have blade problems as well. It gets to really be those forces that I talked about that are acting on the blade. You try to make the blade as light as you can, as efficient as you can for moving the airflow through the engine, but then all these physics start acting on it and you have problems. So CFM has had engines that have blades fail and cause damage to the airplanes, as Rolls-Royce has. There was an A380 that belonged to Air France that threw a blade in Iceland. And we actually spent, not we, but the industry spent about a year up there in the snow looking for it, and they found it eventually. It's a problem that's across the board in the industry. It's going to get a lot of attention now, especially since so now we have a real driver. I hope they treat this as if it was a really bad accident. There's a saying in aviation that all the rules are written in blood, and the FAA pays attention when we kill 200 people. But if we just have an incident in the past, the FAA didn't pay much attention to it. Well, that's changed somewhat. It's been helped along by the focus of the press, even though they've had so much inaccuracies in the press. The FAA knows that the press is looking over their shoulder. So it looks like they are going to treat this like it was a very, very negative event. And maybe we'll get a better inspection method developed for blades that will not only help find the problems in the Pratt & Whitney engines, but also in the other engines, so that we can put blade failures behind us.
Is this a failure of the FAA and their certification process?
I wouldn't call it a failure, but they have some involvement, yes. So it isn't just the manufacturer. And don't forget, we've been pushing technology on these engines for a long time. We want them to be more fuel efficient, so we've raised the temperatures internally. You know, most people don't realize that the temperature inside an engine, without the airflow going through it, is hot enough to melt the engine from the inside out. So how do they do that, prevent it from melting? By putting enough airflow through the engine so that it cools it down. So instead of being 2,500 degrees centigrade, it'll cool it down to being 1,800 degrees centigrade, just below the point where it starts to melt the metal. That means more complete combustion on the fuel, lower emissions out the back end, no unburned hydrocarbons going out the exhaust of the engine, getting into the atmosphere, and we have a better performing engine so that we can go further on less fuel. There's a price to be paid for that. And the price is wear and tear on the engine and the cost of replacement parts and sometimes these events that we see. But I'm sure that we're going to get through it. The manufacturers will get through it. They're all looking at it. On that event that occurred in 2018, all three major engine manufacturers were keenly involved and aware in what was going on because they all have the same problem. So they're all sharing data. They're all trying to share solutions because it's not in anybody's best interest. Boeing, Airbus, or any GE, Pratt & Whitney, it's not in their best interest to have these issues. So they're all working together to try to sort this out.
And then finally, last question. Given the nature of trying to keep blades light, the design of this blade being hollow, if you will, to an extent to minimize the weight or maximize weight efficiency, and I guess another way to put it, other materials, whether it's ceramics or different types of metal, even composites. What's the story with those types of things being used in place of a metal blade that may be more stout and less subject to fatigue, cracking, and that kind of stuff?
For more than 10 years that I know, all three manufacturers have been working with composite blades and ceramic blades. They have their advantages and they have their disadvantages. They haven't come up with the right combination yet. You know, ceramic blades are 90% the best option, except when you hit it with something. It's like pottery. When you got this vacuum cleaner going down the runway to take off and it sucks up a stone, a nut or a bolt that fell off a piece of motor vehicle that was out there, and it comes into the engine and hits it like a ceramic pot, it's going to shatter. Now you've got a big problem where metal blades will take the hit and normally nothing happens. You'll find it on the next landing the vibration, maybe the crew will see the vibration, and then you have to do some work. So ceramics have their own problem. Composites also have their own problems. So there's a lot of work going on in the industry on metal and non-metal blades trying to find the right combination. And they've spent millions, if not hundreds of millions of dollars trying to solve that puzzle. We haven't solved it yet.
Well, I know that you and I could continue this discussion at least for another hour, because always have a lot of questions, and I know that the audience really appreciates the in-depth discussion. From the standpoint of where the investigative process goes, and I know that hopefully the NTSB will figure things out in short order, get the information back in the industry. We have had failed blades in the industry for quite a long time. So why is it that we can't come up with a solution to this problem?
Because the dynamics of this problem are difficult to understand, and our materials that we have to work with haven't been able to deliver what we need to have delivered. So when you're mixing up the alloys to make these metal blades, we haven't got the right metal alloys yet. We may not ever have them. Right? So that's why they've been looking at ceramics and composites. What's not seen by 99.9% of the people in this world is the work that goes on behind the scenes. There is working groups at the engineering level between all the engine manufacturers, not just the big ones, Williams and some of the other ones, are all in this, and they meet together, sometimes more frequently than others, depending what's going on. I can guarantee you over the next 6 or 8 months, there's going to be a lot of meetings on fan blades. They're sharing what they know, trying to come up with the formula to move past this. It's not easy. It's not easy. If it was easy, we'd already stalled it after the 2018 event. So it's going to take some time, and it's beginning to look like it's going to take a lot of money.
Yeah.
For the next show, Greg, I've arranged to have somebody who was a certification engineer for both Boeing and the FAA, and now he's an independent DER, and he's going to talk to us about the certification for engine cowling. I just talked to him earlier today, and he's agreed to come in and explain to us and the audience just what it takes to certify this cowling on the engine. There is a number of FAA requirements that have to be met for this cowling. It's a complicated process. I was looking through some of the material he sent me earlier today, and it's going to be an interesting discussion for those people that want to get a technical discussion about how we certify engine cowling.
That's awesome. I'm looking forward to that one. That'll definitely be, I think, interesting, because the engine cowling right now is taking the hit in this particular event. I'm looking forward to that discussion. And we want you to give us your impressions, your questions, your comments regarding not only this show, but any show that you've listened to. John and I are always available to entertain new subject areas or answer questions if we didn't cover it in a show. You can always contact us via our email at flightsafetydetectives@gmail.com. And we talk about it on every show, about the fact that we have some great listeners who bring up great subject matter as far as what they want us to talk about. They made great comments, and of course, the questions they ask cause John and I to either go back and discuss it or have to do a little more research. We try to find subject matter experts based on some of these questions or comments that we can get to explain it. Maybe a little better than John and I sometimes, but we really appreciate our listeners. And of course, we appreciate our sponsors, PAMA and Avemco. And I know that John has been very instrumental in trying to answer a lot of the discussion questions that I know that are floating out there about this recent event. So with that, my friend, I will let you end this, as I always do, with the last word and talk about our sponsors and close the show. Okay.
Well, today I sat around for a couple hours and answered a lot of questions from our listeners. There's many more in there. I'm amazed at how many comments that we are getting. I just want to remind everybody, if you need insurance, give Avemco a call, 888-879-0389 or avemco.com. And again, mention Flight Safety Detectives, you get a discount. And to all our listeners, please stay safe in your personal life. Wear a mask when you go outside. Don't have large gatherings with people. Don't assume that your family is safe, because Christmas time showed us that all those family functions had a huge spike that took us until just recently to finally work through. A lot of people died, and a huge spike of numbers of people who got this virus because of Christmas and the holidays. So please stay safe. Wash your hands. Wear a mask. Avoid crowds. Don't eat in restaurants on the inside. Eat outside. Just play it safe. And if you go flying, and many people have not been flying, so please, when you go out, take your time, do your due diligence, make sure you plan properly. The United crew had their flight plans. They had their thoughts in an order. When this happened, it just clicked like clockwork right on, and they did an excellent job. All of us in the general aviation community can do the same thing. So do your pre-flight as thoroughly as you can. Make sure you understand how to do a thorough pre-flight. And then when you go flying, please make sure you have enough fuel on board and pay attention to details. So please, fly safe.
To listen to more episodes of the show, go to FlightSafetyDetectives.com or the Professional Aviation Maintenance Association at PAMA.org and wherever you find your favorite podcasts. Catch us next time when John Golia and Greg Fife talk about all things aviation. Thanks for listening.